Welcome back to this third lesson on Pythagoras. This was all about solving problems. So recognizing when to use Pythagoras and then using it to solve the problems, all right? I'm just going to show you one example. Then I've done a big worksheet on this so you can really practice hard then, okay? And have a go at these yourselves because I can't show you all sorts of problems you might get, all right? I'll show you the general outline and then you've got to be resilient and strong and solve problems yourselves. Okay, so this is off an old exam paper. So this square, PQRS, so yeah, this square here. All right, this square is made by joining the midpoints of the square ABCD. Oh, I can see that. So S is in the middle of A and D, and Q is in the middle of B and C. The square has length of sides 30 centimeters. Oh, I guess so. That means hang on. So that means that these are all they're all 30 centimeters then. That's 30 because it's a square, and that's also 30 centimeters. This is a square. Okay. Find the length of one side of the square PQRS. Okay, or perhaps I'll work on this one by then this length here. Okay, so it's about spotting, right angles. See, this is a square. There's a right angle there, a right angle there, a right angle there, a right angle there, and I can see that. I can see there's a right angle triangle. Perhaps I'll try and do a different color without breaking my computer. Well, so I'll try highlighting. You see it? There's actually a right angle triangle here, which I can use. So what I'll do, I'll redraw this right angle triangle, and that's often a good skill to have, actually, being able to draw the part of the picture you care about. I only care now about this yellow triangle. That's a right angle there. See, that's P, that's B, and that's Q. And this is my target here, okay, because this is the length of one of the sides of the square. Okay, have I got any lengths? Yes. This must be 15 centimeters here, okay? See, because all this is 30, and it says that these are at the Q's at the midpoint. So half of 30 is 15, and this one here would also be 15 as well because it's also half of 30. So remember Pythagoras, label my sides, C, B, A, write the theorem down, A squared add B squared equals C squared. So A squared is 15 squared, which is 225. B squared is also 15 squared, which is 225. C squared then is 225 add 225, which is 450. And remember now, to find C, take the root of 450. Okay, so on the calculator, root 450 gives you 21.21 centimeters to 2 dp. So all you've got to do today really is spot a right angle triangle you can use, apply Pythagoras, and then you win. Okay, so for the main task, I posted a worksheet full of exam paper questions on Pythagoras problems, and all the answers are on the mark scheme at the end of the document. But obviously, have a go at the questions first, then look at the mark scheme. If you get a bit stuck on some of these questions, that's fine because they are quite difficult questions. So that'll be the main task, all right? So have a go at that, and then come back to me for the checking question. Okay, oh, sorry, yeah, I did have some more space there, but I didn't need all that space. So here's the checking question, okay? So perhaps try and solve this yourself. Pause the video, have a go, and come back to me when you know if you got the correct answer, okay? This was actually quite easy. So a ladder, which is 7.8 meters long, yeah, I can see that, is leaning against the wall as shown, I can see that. The foot of the ladder is 2.5 meters from the wall, I can see that. Find X, the distance the ladder goes up the wall. Give your answer to a sensible degree of accuracy, no problem. Well, the first thing, luckily, they put the right angle in here. And if this is X, then surely this is also X. And these two are exactly the same size. So hopefully you can see I've got my right angle triangle for Pythagoras. Okay, so C, B, and then this one's A. So as always, isn't it? A squared plus B squared equals c squared. So a squared, I don't know yet. B squared is 2.5 squared, which is 6.25. C squared is 7.8 squared. And I haven't memorized 78 squared yet. So 7.8 squared gives you 60.84. Memorize that one next time. 60.84. I remember from the previous lessons, something at 6.25 is 60.84. So I'll just subtract. I'll do 60.84. Take away 6.25. Okay, so take away 6.25. And you get that a squared is 54.59. So remember, to get a, take the root of 54.59. So if I root this, you get 7.39 meters, and that's 2dp. Remember, okay, this actually was called x, wasn't it? But the only one interesting thing here, okay, is this statement here. Give your answer to a suitable degree of accuracy, a sensible degree of accuracy. All right, well, this is a bit more advanced, but I know we can cope with it. So if you look at all the data you've been given, this year is only given to 1dp, and that's only given to 1dp as well. So really, a sensible degree of accuracy for my answer would also be to 1dp. Okay, so if you look at this now, you go 7.4 meters if you want to 1dp, and now I'll get you the extra mark, okay, because really your answer shouldn't be more accurate than the questions, than the data you were given in the questions. Okay, so that's it for this topic. We're all done. Thanks for listening, and we'll see you soon. Goodbye.